Hey, this is Amber. Welcome to my CC channel. I'm a longtime Classical Conversations mom. We started when my oldest was just 5 years old, and she just finished her first year of Challenge in Challenge A. And last year was my first year of directing. I was our Challenge A director, and it was a little terrifying last summer because I had never sat in on a challenge class before, a full day at least, and I wasn't quite sure I knew what I was getting into. And then I heard we had a new math program, and then I was really terrified. So I learned that there's a big support network of other people, and there's some great lesson plans, and that helped me with all of the subjects except for math, which was new. And so I took that time to tackle the math map and going through the naturals with my girls over the summer, and then doing all the book clubs and reading the material, and sometimes doing my own outside research, watching all the tutor training videos that they had on CC Connected for tutors. Um, well, just the one video that Dr. Gulpin uses to kind of go through everything. And then I made my own lesson plans following the guideline of what Dr. Gilpin shows from the CC for the tutoring, and made that available to other directors, either through Facebook or the band group. And so I think the lesson plans were helpful to a lot of people. And towards the end of the year, when the material started getting really complex, I started recording these little videos to go through the lesson plans. And I think people found those to be pretty helpful to have the example of how to like walk through the actual lesson plan. And it just helped people feel more confident with going into directing their own classes, in case they wanted to take some parts of it. So I will be doing this video series because now I'm going back and filming the earlier weeks, because I think I had started somewhere around like week 19 or 20. And so I need to go back and do all the original ones. So that's what these videos are. And normally I'll just kind of jump into things, but just wanted a quick intro. Also, so that you know, this will be helpful for Challenge A directors and Challenge B, because 99% of what I'm talking about will be the same in your Challenge B classes as it is for the Challenge A. There's a little bit of difference on the student pages for the calculations that they might be working through. There might be some differences on the problems, but other than that, all of the other initial stuff, the cover picture, the Memoria pages, the Invention pages, all of that stuff is the same. And a lot of the concepts are still probably about the same level for your 7th and 8th graders. So if you are a Challenge B director, this will be helpful for you as well. And just so you know, the lesson plans that I have, they are, so I always just keep mine digital, and then I keep my iPad. I have my whole lesson plan on my iPad because I don't like to print out everything, but you can print them out. They are going to be available as a link on this video. So I'll put it down in the notes, and it will link out to my Google Drive, where I'll have the most up-to-date version of these lesson plans. So you may be able to find them in like a Challenge A Director group on Facebook or the band group, but I won't necessarily have access to those groups going forward because I'm not directing Challenge A this year. So I wanted to have them somewhere where I could make sure you're always getting the most up-to-date link. And so that's through my Google Drive, and that's what will be below. So you can always just go there and find the lesson plan. So go ahead and pull out your lesson plan. It might be helpful to go through that while we're running through this. The first thing that you do is kind of just warm up the kids' minds. And so you're trying to get them just thinking about math and trying to do a little bit of a warm up. So we have an exordium part, which is kind of they call it the grammar part, which is the first 15 minutes. But really, those first like 5 minutes, sometimes a little less, but the first 5 minutes is meant to be a little bit of a math game to warm their minds up. And so for the first 10 weeks of class, the math game that they recommend is number knockout. And if you are new to CC and you don't know what number knockout is, I'll link below to a video so you can learn what number knockout is. All the kids that have been through CC are very familiar with number knockout. So they're going to come in knowing what to do. But if you're new to it, you can watch that video and it'll help you out. What I found is that when the kids were in Essentials and they would play number knockout, they usually had like 15 or 20 minutes to do that as a math game during Essentials time. They don't have that much time now in Challenge. So we're trying to just give them a little 5-minute warm up to like wake their brains up. And so I found the best way to do this was to do number knockout battleship. And I don't have a number knockout board to show you because we're packing and I've already packed everything up, or I gave it to our next year's Challenge A director. So I don't even have a number knockout board. But pretty much it goes, they have all the numbers. I think it goes till 26. So it's like 1, 2, 3, 4, 5, 6. And then I think it goes down to 36, if I'm remembering correctly. So on the board, I actually printed a copy of the number knockout board, and I had a big laminate copy that I would have on the board that the kids would see. And then I kept a smaller version of a number knockout board for myself, and I would mark a couple battleships. So I would have a battleship that was 2 digits long, and I would have a battleship. So if I threw in some more numbers in here, 17, 18. Okay, so let's say I had another battleship that was 3, and then I would do a battleship that was 4 digits long. And so I would have on my board the 3 ships that I had on here. And so the kids were trying to use their numbers. So we would roll 3 die, and they're 6-sided die. And so you'd roll the die and you'd have some numbers. So, 2, 3, 4. And so they're finding all the ways they can calculate with 2, 3, and 4 to knock out a number on the board. And so when they would knock a number, and they'd have to tell me how they solved it too. So they'd have to say, 2 times 3 plus 4, whatever. And so they'd tell me how they solved it. And I would say, they would solve to 10 or something. And I would say, miss. But if they had a hit, I would tell them hit. And then they knew they were trying to solve the other numbers by there. So they might focus their attention on trying to use math that gave a lower number, so they got closer to that 5 digit, or ways that they had big numbers to try to find the higher numbers, like the 34 and the 35. And so usually within 5 minutes of playing, they could knock out my ships, unless we rolled a 1. And sometimes when you have a 1 as one of your numbers, you just can't get to all the calculations you need. So that was a great way to play number knockout, wake their brains up. We did that for the first 10 weeks, but we would do it as number knockout battleship. And it just made it more likely that they would do that, because we had a hard time. I think, once or twice, if they did the battleship and they were really on a roll, they could try to go to a full blackout where they got every number on the board. But that only happened a few times in the semester. Also, I set a timer for 5 minutes because I really didn't want to keep going with this game. I mean, you could spend the whole math time on this game, but that wouldn't be the point of the math strand, right? So we would just do 5 minutes on number knockout. And then the next thing, so I would always open with the game of some sort. The first 10 weeks, it'll be number knockout. The second 10 weeks, it's I think interesting integers. And then the last 10 weeks, quick flip arithmetic. And as we get to those lessons in weeks 11 and then 21, I'll show you what those things mean. Okay, so the next thing that I do is I would actually have them kind of show me on the map where they are for the week. So when you open up your booklet, and as a director, I had mine all pulled apart, and it was easier for me to keep track of it that way. It was fine for me. For my daughter, she would keep hers bound because she doesn't do as well to keep things nicely organized in their area. So different ways to do it, and it's fine however you find works best. But I would have them go to this page. And so this is kind of our map. And I would say, what is a map? What does a map do? And the students might say, well, it shows your location, or it shows where you are. I'd say, yes, this is our math map. So this is showing us where we are. And so if I look at the top, I have these things called domains. Can you tell me which domain we're in by where you find the check mark? And they would say complex. Or if you're in challenge B, your kids would say monomials. And then I would say, and on the other side, we have dimensions. You guys have heard of the word dimensions, right? So you think of 3-dimensional, or your drawings, which could be 2-dimensional, and something you can pass me or hand me would be 3-dimensional. Well, we're going to learn all about dimensions, and we get to talk about 4th dimension and other dimensions. So it'll be really fun towards the end of the year. So that is where we are this week. And so each week you're opening this up and you're just finding where you are at in the math map. The next thing that we do is go through the cover. And so this conversation about the cover should take no more than 10 minutes. So this is still kind of part of that exordium wake up stuff. So on the cover, we have, you can see 1 up here. It shows us what week we're in. This shows us what level or domain, so complex, or if you have the purple ones, it's the monomials. And then all of our pictures and our quotes and our reflections are all the same. Doesn't matter if you're in naturals, all the way up to transcendentals. Everybody has that same cover. The same next couple pages will be the same as well. So I would show them the cover, and then I would just open-ended question, what do you see? And so they hopefully start talking. They tell me they see maybe an angel, and they see a very sickly looking cow. Um, there's another kind of little angel or cherub or something. There's some words up here. So they might just start picking out things that they see. There's an hourglass, which would be tied to time. Maybe there's these geometric shapes of some sort. Here's a sphere over here. So I just let them free talk. If you have a class that knows you well, they might be more open to talk. I think in my first week, they were pretty quiet because they were maybe new to me or new to each other. And so they'll become more talkative as the weeks progress. But just let them try to find whatever it is that they can find. And then if they're not finding a lot, or you just want to generate some more conversation, I go through and I kind of maybe mention some things that were mentioned on this conversation. I never read this or talk about this in class. I pre-read this and looked through it so I would have some idea on maybe something to focus on for this cover page. And so I might say that this image is called Melancholia 1 by Durer. And so melancholy, has anybody heard that word? You guys know what it means? And then somebody might know it maybe means sadness. And that would be the case kind of in our modern description of melancholy. But apparently in these times, in Durer's times, melancholy in the medieval times was considered to be one of the humors or like one of the fluids going through our bodies. And it might be tied to kind of insanity or creativity. So kind of an interesting take on it, very different from what we think of our modern word of melancholy. And then from there, so we could talk about how there's a magic square maybe up in the top, which is where the numbers kind of calculate, and they, in each direction that you go, they'll still calculate out to the same number. So we can talk through some of the things on here, the different types of shapes. And then we'll kind of move on and do our quote and reflection. So the next thing I would do in class is read through the quote. And so I would read through the quote and then maybe talk about how as believers in God, we recognize how he created something out of nothing. So ex nihilo, which is Latin for out of nothing, God has created everything. And so that's what the quote's talking about too. And then we can read through our reflection and try to tie in how maybe that ties with math and how we see the world. And how math glorifies God's creation. And we're really going to talk a lot about that in math this year. Okay, and then I could say any other thoughts on the cover, and usually they never have other thoughts, but I always throw that in there. Okay, so now we kind of move on to the dialectic part of class, which will take maybe about 20 minutes. And the first thing that we're going to go through is the invention page. And so the invention pages have a 1, or it's a little I with a superscript. So I squared. And then the next page will be I cubed, and then I with a 4th exponent. So it also says at the top, invention. And that's how you know you're on the invention page. These are the same, no matter if you're in monomials or transcendentals or down in fractions. These pages will look the same. These invention and memorial pages apparently will look the same. So, but what I like to do is try to find the things that they're going to care about or they need to know so that they can do their student pages this week and be able to work through their problems. There's a lot of information on these pages, and I think it can be overwhelming, especially for some kids, to think they need to know all this. They don't. Maybe just try and pinpoint and grab a few things, or let them pinpoint a few things that they recognize or they know about or they want to learn about. And so you can do that as an open-ended conversation, like what is familiar on this page? And so you could say something about, zero. They have adding with zero, calculating with zero. Do we like it when zeros are in our problems and we have to calculate with them? Sure, we do, right? Because it makes it a lot easier to do calculations when you have a zero as one of the values. They also talk about hidden zeros. 4 can equal 4. 4 could also equal 4 plus 0 because the 0 isn't changing anything in that value. And so sometimes we get into higher math and there's almost hidden zeros. We have to think about the fact that there could be a zero in there, or there something is equivalent to one. So we talk a little bit about hidden zeros and ones. We also talk about dimension. So in 0 dimension, a point has no width, no height, no length. So how would we even represent that? We can't exactly represent a point because it has no length, width, and height. So instead, we represent it with a dot. And so we use a dot, and we just say that the dot is just our representation of what's meant to be a point, because you couldn't truly draw a point on there and have it have no width, depth, or height, because there's a little bit of each. Okay, so in 0D, you have a point to represent it, a point, and we draw it with a dot. And then you can ask them, what is unfamiliar on this page? And none of the kids in my class had picked this up, but if you have a kid that is really detailed and they're noticing everything, they might notice that they know about whole numbers, they know about decimals and fractions. They should know about mixed fractions. They may not always call them by that term. They probably know about percents. Maybe they've done stuff with scientific, maybe not. They're kind of young for that. Complex, totally new. No clue what that whole complex thing, what those little I things are about. So that's probably something unfamiliar, but we'll talk more about those complex numbers. And so what I say for them is that this little I is kind of represented with the Greek iota, like a little italic I. And that represents imaginary numbers. Imaginary numbers. You think I'm making this up, like it's some make-believe fairy tale thing, but it's not. I said, think about if you were a farmer in the Middle Ages and you have 3 pigs, and I come by and I say, I want to buy 2 pigs. Well, you know, you're going to decrease by 2 and you have 1 pig left. But what if I say, well, I'm going to take 6 pigs from you? And the farmer goes, what? You can't take 6 pigs. I only have 3. Well, because it's a debt, it's a negative. Negative numbers was a weird concept. It didn't come around until later. And so for many years, people didn't even calculate with negative numbers. And then only certain societies did. And a lot of people didn't understand negative numbers. But once you open up to negative numbers, once you understand how they work on the number line, you see how you can calculate with them. And now your calculations really open up. You can do so much more with negative numbers. Imaginary numbers are kind of the same thing. So at a certain point, there was a roadblock hit where mathematicians weren't able to keep calculating with something, with negatives under a square root sign. And then somebody decided, well, if I pull out that negative of the square root of -1, and pull that out and make that an imaginary number, I can keep calculating all the other stuff and have this other little imaginary number. So much like negative numbers, you can't necessarily see them, you just have to conceptually understand them. That's how imaginary numbers are. And we'll get more into those in the future weeks. Okay, the next page that we go to after invention is memoria and arrangement. And so memoria and arrangement is the next page. It has I to the 3rd. So that's how you know you were on memoria and arrangement. It also says that on the top. And so here we're just talking about dimensions. And if you remember in practicum, they probably went through dimensions. So you maybe could represent 0 dimension as just 1 point. So point a finger. That's just your 1 point for 0 dimension. So just a point, no length, no width, no height. And then you get into 1 dimension. So 1 dimension is going out in a straight line, right? So you have your length that you can include as well. Now, 2nd dimension is going to be a plane. So you're going to go out one way and over in another. So like that. So you have length and width on 2nd dimension. 3rd dimension, let's see, I'm going to make my head be one way, and then I have an arm going out this way. So I have my height and my width and my length. And so now I have 3 planes, and that's my 3rd dimension. And so you can keep going on from there. We'll go through some of the later dimensions in the later lessons. But that's pretty much what they're showing you here, is which dimension, which kind of spaces do you have? How many planes do you have? And so those are some of the things that they're just reviewing for you or introducing you to on here. One of the words that maybe is a little unfamiliar, you haven't seen before, is this word vector. Did anybody see Despicable Me, the first one? Remember the name of the bad guy in it? His name was Vector. And at one point he says, let me see, I wrote it down. He says he wants to be named Vector or called Vector because he's committing crimes with direction and magnitude. So magnitude is meaning the amount. So like if I said I was traveling in a car 65 miles per hour, 65 miles per hour is my amount. But a vector has direction and magnitude. So the direction would be north. So 65 miles per hour north. That tells you my direction and my magnitude. That would be a vector versus a scalar, which is just the shape of the magnitude, the amount, or the amount of the magnitude, which is 65 miles per hour in that case. So little bit of vectors. We're going to talk more about those in future weeks too. And then we get to talk about 4D stuff later, which will be a lot of fun. Okay, and then the last thing we might talk through, I usually didn't really talk much about the charts other than to let the kids know, don't forget that you have your charts. The first week, the charts are not necessarily, there's a lot of kind of general information about math in this first week. Then the following weeks, it's going to be very similar to what the pages look like for the student pages as they go through their calculations. So they'll refer to the charts when they don't know the equation for something or they're forgetting how to do something. The charts will be kind of that encyclopedia of knowledge on how they find the answers to things. So the charts will be very helpful in the future weeks. And I'll also mention to the kids that each week at this point in time, I'd kind of ask you if you had any problems with anything of last week that you wanted to talk about or show. I never had my kids come back and ask me questions or ask for help. So either their parents helped them out or they figured out most things. So, and then normally we would take now probably these last 10 minutes of class, 10 to 15 minutes, to go through the tops of the student pages. And let me grab my pages. Okay, so after memoriam arrangement, when you turn to the next page, you have started the student pages. The student pages are numbered 1 through 16. And it tells you up here, so I'm still on week 1 of Ex Nihilo. I'm in complex. It always starts with the little flashcard, and then you'll see that at the top of every 4th page. So page 1, page 4, or sorry, 5, 9, 13, I think that works out. Normally, in a week, we would work through this upper section and solve those student problems. But week 1 is different than all the other weeks. So week 1 is different because the idea with week 1 is that your students have already read through this booklet before they showed up for class on the first day, and hopefully their parents have looked through this booklet before the first day, because the student pages are more so introducing the math map to the families. So the tops of each of these sections are going to talk about what the parts of the math map booklets are. So it has that you have a booklet cover. The next one says the contribution to the conversation. Next page is talking about the actual math map. They go through and talk about the flashcards. So they're introducing them to all the parts of the math map that they use. The middle sections for this week are more what the kids can actually try to practice or do an activity around. And so those are the ones that they can more work through when they're at home. And then the bottom section for each of these pages, just on this week again, talks about seeing the unseen booklets. And so I had my kids bring their Seeing the Unseen booklet along with their week 1 booklet to the first day of class. So I told the parents ahead of time, have them bring this booklet as well, week 29's Seeing the Unseen. And so what I do is how we're talking all year about how we see math all over our environment and in God's world. And we think about how we see God within mathematics. And so when you find an example of something like that, or you see something, go ahead and just jot it down in your notebook. This is just meant to be in this Seeing the Unseen booklet. This is meant to be a place where you can just record your notes of how you're seeing math in your world. And so then I said, okay, now everybody stand up. And so everyone in my class had to stand up. And I said, everyone think of an example where they see math in their life. And I gave them a few minutes. And I said, okay, does everybody have their example? And they'd say, yes. And I'd say, raise your hand if you have your example. And they'd raise their hand, and I would call on somebody. Okay, Greta, that's my daughter. What's your example? And she'd say, I can see this table right here is a rectangle. Great, that's a great example. You can sit down. Okay, the next person with their hand up. Okay, what's your example? Great, sit down and write it in your book. So each person, I told them, go ahead and write it in your book. Write it in your book. And so as they sat down, they all wrote their first example of seeing the unseen, seeing math in the world, and they would write their example in their book. And I said, and they all were able to think of an example. And I said, great, see, you guys are already mathematicians, and never let anyone tell you differently. And so they all had an example on the first day. And my goal was that that would help them realize I don't have to hold on to this booklet and wait and do something pristine and perfect. Just jot my notes as I'm thinking of things. And the way I would use my Seeing the Unseen booklet as a director, as I was doing things, it was last summer, so I was talking about box gardens, and I was thinking, well, you have to care about distance of the seeds and temperature and what can plant in certain zones, and then the time, how much time do you have until you harvest certain areas? How do you want to time out your tomatoes so that certain ones you have now and then some later in summer? And so I would do things like that, or I would think of examples as we're playing sports and stuff, or if I was watching other videos to try to understand a concept, I might put some extra doodles or drawings together. And so just a quick flip of kind of what my, I had this thing about bases. Oh man, bases are their whole other deal. We'll talk about those maybe next week. Scalar versus vectors, air hockey. I have like a little Superman display over here. I was watching the X Games, and the snowboarders are spinning around, and they name their spins based on how many rotations they're doing around. So a bunch of different examples. Okay. So a couple things on planets, and that's as far as I got. So that's kind of what I had for my Seeing the Unseen through the last year. So I might share that example. I had a few examples written in here at the start of the year, and so I shared those with the kids. But it's not meant to be perfect drawings or anything perfect. It's meant to just be some of your notes as you think of things and jot things down. Okay, and then I went through the catechism with them, which I had actually, so the catechism is where it says, where are the solutions? Where do my parents find help? All that kind of stuff. What is it? What are the solutions for? To check work or work backwards. What's the inside back cover for? To see the unseen and fill in the lesson 29 booklet. What's the back cover for? To play games with my family. So there's a couple more questions. They wanted us to go through these so that the kids knew where they're finding their resources. And so I actually printed out those questions for the kids on the first day, and I had them write in what the answers were. And then the next few weeks, as we're going through and they're answering these, they could just flip real quick to their brain book, and they would have all the answers already there that they needed for each of my questions. And so the first week, this took a few minutes, like 5 minutes, because they had to write out their answers. But on the subsequent weeks, this is a quick little 1 minute. I just ask the questions, they quickly give the answer, and it goes pretty fast. So there you go. The first week is a little bit different than the others because the point of it is for them to kind of start understanding how math works. You don't see a lot of calculations and actual numbers, which kind of terrifies some of the parents because they wonder where the math is. But this week is kind of like the pre-math. We're not really doing all the calculations and numbers yet. That'll come next week, which is fine. This is almost like a little introduction. So as long as your parents kind of have that heads up, and the kids just get used to the feel of, we have the exordium, we're going through the covers, we're going through these pages, we'll talk through some of this stuff, we'll work through some student problems together. That's what the math strand will be like going forward. So hopefully this was useful to you. Thanks so much for watching, and we'll be back next week to talk about number notation.